Okay, the reason why this is in your module is because we were having some difficulty with third period today trying to Zoom with the folks at home. So anyway, this is your test review and hopefully you'll do great on the test. You will need your rules for rotations nearby or you will need to have them memorized. So when we're looking at number one, segment XY has the following coordinates. What you are trying to do is figure out which quadrant they would be in after a 90 degrees counterclockwise rotation and a 90 degrees clockwise rotation. Let me get that a little better. So try that and that. Okay, first thing that I want to do is I want to sketch out the 4-quadrant grid. Okay, if I'm going to locate that segment, XY is going to be in quadrant 3 because they're both negative coordinates. If I rotate 90 degrees counterclockwise is this direction, so that means it's going to be in quadrant 4. And if I rotate the other one clockwise, it means that it's going to be in quadrant 2. Number 2, Marcos has a square sprocket, ABCD, graphed in the coordinate plane. Here are the coordinates after a 180-degree rotation about the origin. What are the coordinates? So they are giving us the image. We have to work backwards to find the pre-image. So what I want to do is I want to think about what the rule is. The rule is if I rotate 180 degrees about the origin, then my new coordinates are the opposite of x and the opposite of y. Okay, so my new coordinates for A prime is negative x, negative 3. So to work myself backwards to figure out what A was, then I need to get rid of the opposite. So it's going to be a positive 6 and a positive 3. Okay, I'm just working that backwards. Now I can check it again and I can see if it would go the correct way. If I did the opposite of x, I would get negative 3. If I did the opposite of y, I would get negative 6, negative 3. Okay. Complete the following table. So here are your rules. So if I do a 90-degree rotation, my x and y flip-flop. Okay, and the y is its opposite. 180-degree rotation, they both are the opposite. A 270-degree rotation, they flip-flop, and this time it is the y that is the opposite. So think about when you're doing those, what I would do is have an index card or a sheet of paper or something nearby, and I would have a 4-quadrant grid just drawn out like this with x and y. So, and then I would just rotate it. So if I'm rotating 90 degrees counterclockwise, if I were to move that grid, that's going to put the y over here and the x up top. So you can see that the axes flip-flopped. Here's the other thing. All your negative numbers would be over here and positive would be here. So that's the reason why we would have the negative sign right there. Okay, so when I do the clockwise rotation, the one thing I know is that this isn't going to change. That's going to be the same. Okay, so if I did a 90-degree rotation clockwise, okay, so again, remember, this would be your original figure. If I did a 90-degree clockwise turn, that's going to put, again, you have your x and y axis change because that's going to look like this here. So this is going to be your y. So the x and the y flip-flop. Sorry. And you can see that your x is now going to be down in the negative. Okay. And then over here, this is going to look just like your 90 degrees counterclockwise rotation. Okay. All right, next page. Hopefully the next page is an easy question. You're just looking at a transformation of triangle ABC. It's rotated 90 degrees counterclockwise, and it is dilated. You can see that it's changed size. Number 5, you want to look at the polygon and figure out which of the following transformations will map it onto itself, so it'll look the same. So if we did a reflection about line EF, that is going to just move this over here and vice versa, here over here. It's going to look the same. A 120-degree rotation will not make it look the same, but a 90-degree one will. Okay. And then a reflection of across the line segment DC is going to put it out here, obviously not mapping it onto itself. Okay, we are going to rotate W, X, Y, Z to form W, X prime, Y prime, Z prime. And we're going to answer some questions about it. So the first thing I'm going to do is I'm going to look at point W. That's the point of rotation. And I'm going to pick out the shorter segment. I'm going to look at WX, the pre-image. And then I'm going to look at what happens to it after we do a rotation. Okay, so the first thing that we need to do is we need to rotate counterclockwise. So if I go counterclockwise, I'm going to take the pre-image of WX, move into a counterclockwise rotation, and I see that big angle. That angle is way more than 90 degrees and way more than 180. Is it more than 270? Well, if I look at it, 270 would probably, that's going to make that a right angle. So that would be 270. So yes, it's more than 270. So what we've got is a rotation that's between 270 and 360 degrees. Let's see if I can squeeze this down a little bit. The range for the number of degrees for the clockwise rotation, so if I make it go clockwise instead, I'm looking at the pre-image of WX and I'm rotating here. Okay, so that is going to be somewhere between 0 and 90 degrees. Okay, because again, 90 would be if I went all the way to here. Okay, so it can't be more than that. Also, these two right here, if I knew exactly what they were, they should end up adding up to 360 degrees. Number 7, Dave is creating a stop sign. The stop sign is a regular octagon. And he wants to rotate the image so that it maps onto itself. What is the center of rotation? Okay, so the center of rotation, I can look here to find my horizontal center. So that is 4 units long, so halfway would be right here. So I'm looking at a line that kind of, if I want to kind of visualize it like that. And if I look at the vertical halfway mark, if I look at CP, again, that's another 4 units, so halfway would be right here. So if I line those up, my center point is right there, and that coordinate in the form of x comma y is 0, 1. Number 8 is a hexagon. Complete the sentence. One way to carry a hexagon onto itself would be to rotate it around point 1, 0. So 1, 0 is right here. That's the halfway point. That's the center. And remember, what you learned is if you take any regular figure and divide it 360 degrees and divide it by the number of sides, that's going to tell you the degrees of rotation that'll map onto itself. So in this case, we have 360 degrees by the number of sides. So any interval or any multiple of 60 will map it onto itself. You only have 60, so that's your only answer. Number 9 was very mean of me. Actually, we don't want to do number 9 because it is going to be in the next section. So you're going to see this question again, but this is called a composite transformation, meaning that you're going to have more than one, and we haven't learned how to do that yet. Number 10, we have the quadrilateral MATH. Explain why, when you rotate 90 degrees about the origin, and 90 degrees is counterclockwise, so that would be this way. Vertex M prime shares the same location as vertex H. So if we rotate it 90 degrees, it should end up here. Well, why? So when you rotate 90 degrees here's your rule. X comma y would end up being negative y comma x, okay? So think about what your coordinate is. The coordinate for M is -2, comma, -2. Well, when you rotate 90 degrees, you flip-flop and the y becomes its opposite. That's your mathematical reason right there. Number 11 is just writing your rules down again. You have polygon ABCD, and we're going to rotate it clockwise. So we're going to write those rules down. The first two that we should know without really having to think about, so it doesn't matter which way we go, this is going to be its opposite for each x and y, and this stays the same. When you rotate 90 degrees clockwise, the x and y axes flip, and the x becomes its opposite. When you rotate 270 degrees clockwise, the x and y axes flip, and the y becomes its opposite. So you're just going to complete the table from there. So I'm just going to kind of fill in the first, and I'll let you fill in everything else. The y's stays the same. The x changes to its opposite. For the x and y rotation, they stay in the same position, but they change to their opposites. All right, the x and y changes, and the y becomes its opposite. And the last one stays the same from the original. And then you can complete that. If you need me to help you with it, I can. You're almost finished. Number 14. I feel like I skipped something. Number 11. Yeah, I don't know where 12. I guess we're missing a page in there. So listen carefully. Number 12 is the question about Sakura, rotating 180 degrees counterclockwise about, or clockwise about the origin. Is her work correct? No. She actually did a rotation of 270 degrees counterclockwise or 90 degrees clockwise. Okay. Number 13, it says select all that apply if you're going to find out what transformation always carries the figure on itself. There is actually only one answer there. And the only answer that maps it onto itself would be B as in boy, a reflection across line S. Now let's go to 14. Let's see if, yeah, that's it. I don't know what happened to that page. Okay. Number 14, this is a great question. We have triangle ABC. It's shown on the coordinate plane. It's going to be rotated 180 degrees clockwise, not about the origin, but about 0.34. So right here, that's 3/4. So that means C is going to stay the same. So if we were to rotate that, if I were to sketch it out, it's going to kind of look like this. Okay. That's 180 degrees. So we're going to select all that apply. On the EOC, if you select 2 and there are 3 answers, you're going to get it all wrong. If you select 1, you're going to get it all wrong. If you select 5 and there's only 4 answers, you're going to get it wrong. So take these slowly. It's saying what will be the same. So will the coordinates of A prime be the same as A? No. You can see that A is over here, A prime is over here, so no. What about the coordinates of B and B prime? No, there's B prime. What about the perimeter of ABC? Well, what we know about a transformation, the rotation, is that angles are preserved and lengths are preserved. The shape is preserved. So if the side lengths are preserved, then the perimeter or the distance around it is going to be the same. And if the perimeter is the same, the area is the same as well. We also know that angle measures are preserved. So the angle of B prime is the same as the angle of B. And we know that lengths are preserved. So segment AB is going to be the same as segment A prime, B prime. So you actually have 4 answers there. Hope that was good. Make sure that you try the extra credit through Math Nation.